Continuing with Chapter 7, which deals with analytic trigonometry, we're now into the section dealing with basic trig equations. All right, so we already looked at inverse trig functions, and they kind of play a role in this section also. So we're going to solve some basic trig equations. Now, we're not going to do the solving by factoring. That's going to be held off until the next course. So this is going to be our final topic in this course, which is just the basic trig equations. All right, so any equation that contains trig functions is going to be called, not surprisingly, a trigonometric equation. So they give you some examples of trig equations. The first one being sine squared theta plus cosine squared theta equals 1. We had called that actually the Pythagorean identity. So that was actually true for every value of theta. But then the second two are actually only going to be true for specific values of theta, and those would be called then conditional equations, right? Because they're only true when theta takes on certain values. So as with any equation, you're just trying to find all the values of the variable, which in this case is theta, that make the equation true. So that's no different than any other type of equation. So really what ends up happening is any trig equation you should be able to boil down eventually to what they're calling a basic trig equation, and that's just going to be some trig function equals some constant, right? So like an example of that would be sine theta equals 1, or cosine theta equals negative a half, or the tangent of theta equals 6, right? Because here you just have some trig function equal to some constant. A trig function equal to a constant. A trig function equal to a constant. So those are basic trig equations. So here's the first one. Solve the equation sine theta equals 1/2. So the first thing you really want to think about here is if we have our sine function on any one period, let's say from 0 to 2 pi, it's going to take on each of its values twice with the exception of 1 and -1, right? It's only going to hit 1 at one place, pi over 2. It's only going to hit -1 at one place, 3 pi over 2. But every other value, it's going to hit twice in that period from 0 to 2 pi. So that's something that you want to keep in mind, right? Because when we did an inverse trig function, we were only getting back a single value. So just doing an inverse trig function is not going to give us all the solutions to a trig equation. It's only going to give us one because it's a function. So we're going to often have to find that second solution. So in this case, we have sine theta equals 1/2. So if we remember our old friend ASTC, right? We know that the sine function is going to be positive in both the first and the second quadrant. So what's going to happen is this should have a solution in both the first and second quadrant. And then they draw this unit circle here, and they remind you that, well, at pi over 6, the sine, right, which was the y value, was 1/2. And then it's also going to be 1/2 at the corresponding angle that's in the second quadrant, right? 5 pi over 6, right? Because 5 pi over 6 is the angle in the second quadrant that has a reference angle of pi over 6. So in this case, like our theta hat or theta bar, whatever we wanted to call it, was pi over 6, but we also needed the angle in the second quadrant that has a reference angle of pi over 6, which was 5 pi over 6. Okay, so there's our two angles, pi over 6 and 5 pi over 6. But then if we go back to our sine function, we realize, well, okay, that's fine. There's pi over 6 and there's 5 pi over 6. But what's going to happen is this is going to repeat because of the fact that sine is periodic. So yes, it's going to hit 1/2 at pi over 6, but then it's going to hit 1/2 again at 2 pi after that, which would be 13 pi over 6. And then it's going to hit 1/2 again at 2 pi after that, which is going to be 25 pi over 6, and so on and so forth. And it's going to do the same thing as you go to the left, right? Pi over 6, then -11 pi over 6, and then again, -23 pi over 6, so on and so forth. And the same thing is going to happen with 5 pi over 6. It's going to then reach this value again, 2 pi after that, which is 17 pi over 6, and so on and so forth. There's another value, and then if we went to the left, we would get more values. So because of the periodic nature of the sine function, what we're going to have to do is we're going to have to remember you're just going to keep reaching this same value as you keep wrapping around the unit circle. And wrapping around the unit circle, what we're doing is we're adding 2 pi or subtracting 2 pi to each of those values that we ended up with, right? So one of the solutions is actually going to be pi over 6 plus 2 pi k, because remember we had used that notation to represent 2 pi times any integer. So pi over 6 plus 2 pi k is going to be one of our solutions, and our other solution then is going to be 5 pi over 6 plus 2 pi k, because again, we're just going to keep wrapping around the circle, right? So there's your 5 pi over 6, but then if I wrap around again, I get back to that same angle, right? They're coterminal. Wrap around again, get back to the same angle, right? So on and so forth. So you're actually going to have an infinite number of solutions here, okay? And then they just go through this process. So you know that the solutions between 0 and 2 pi were pi over 6 and 5 pi over 6. However, as you keep wrapping around the circle or realizing that the sine function is periodic, that's going to happen every 2 pi units to the right and every 2 pi units to the left. And now here they're using k, so now they switched up their notation on us, which is good. K is what we wanted to use. They had been using n for any integer, now they're using k, so that's actually a positive. Now, if you're going to solve the equation tan theta equals 2, now the nice thing about tangent is tangent actually only takes on each value once per period, right? And if you remember, the period of tangent was pi and not 2 pi, but the nice thing is, like I just said, it only takes on each value once in a period, right? Because you can see each period is basically a one-to-one function, right? It passes the horizontal line test, so it's only going to take on each value once, which is a positive for us because then when we solve an equation involving the tangent, we're only going to have to find one solution per period, right? And then we're just going to be adding pi k because the period of tangent is only pi and not 2 pi. So let's go back to our PowerPoint. So if we're solving the equation tan theta equals 2, well, 2, this was not a trig real value. So because it wasn't, what we would have to do is solve on the calculator by taking the inverse tangent. So what we do is we go to our calculator and we do inverse tangent of 2. And again, what is this going to give us? It's going to give us the angle between negative pi over 2 and positive pi over 2 that has a tangent of 2. And what is that angle? It's 1.107. And actually, this PowerPoint is slightly off. The PowerPoint is telling us it's 1.12. It's actually 1.11 if you're going to round to 2 decimal places, right? Just make sure we're in the correct mode. Yes, we're in radian mode, so this is a glitch in the PowerPoint, right? So it shouldn't be 1.12, it should actually be 1.11, let's say, all right? But again, if you look at the picture, cross this with the graph of y equals 2, there it is, 1.11, which again, the calculator was correct. The PowerPoint was off. But then what's going to happen? That's going to repeat every pi units after that to the right, which is 4.249, and also every pi units to the left of that, which is negative 2.034. Okay, so our solution is going to be not just 1.11, but the full solution is going to be 1.11 plus pi k. All right, so it's really a two-step process. You want to first find the solutions in one period, which is just 1.11, and then you want to find what's called the general solution. That gives you all the solutions, right? And how do you get all the solutions? You just basically keep adding pi or subtracting pi from your original solution. And again, this is not 1.12, it's actually 1.11. So tangent is actually a bit easier because of the fact that there's only one solution per period, whereas sine and cosine, there's going to be two solutions per period.